The other trigonometry tool you have for non-right angle triangles is the sine law, where you take the sine of one angle divided by the length opposite to it and equate it to the sine of the other angle divided by that length. So I've got this sort of setup here. I'm going to choose this one to be alpha. So that's going to be 40 degrees in my equation here. I look across the triangle to the side that doesn't touch it. That's going to be my A. If I do the same with this angle, take a look at this. That's going to be my beta. If I look across the triangle to the side that doesn't touch it, that's going to go in the equation where the big B is. So if I take this information and I plunk that in there, I end up with sine of 40 degrees divided by 10 is the sine of 65 degrees divided by x. Okay. Now, first thing, I have my variable in the bottom, and that's not where variables go. They need to go on the top. So this fraction is inconvenient in that form, so I'm going to flip it upside down, like so. Now, that's okay, as long as I have another fraction on the other side that I can also flip, so that I've got matching things on both sides. So if I flip this one, so the idea there is that if I take this and divide it by that, I would get the same number as if I did this divided by that. So if I did it in reverse order, this divided by this should give me the same as this divided by this. And now my variable's on top. So maybe just make a note to that yourself. Get the variable on top. Should be your sort of first priority, because you can't solve it unless that variable's up there. All right, I have two sines that I can evaluate using a calculator. So sine of 40, sine 40 is 0.643. And sine of 65 is 0.906. Now I can do this division. 10 divided by 0.643 gives me 15.552. And I need to break this division. You break division by multiplying, so multiply the other side by 0.906, and I will have the x all by itself. If I do that, I end up with 14.09. Okay. Now, it's good to go fact check your answers. The biggest angle should always be across from the biggest side. That's just how triangles work. So across from a 40, I have a side length of 10. Across from a 65, I need a side length that's bigger than 10, because this angle is bigger than that one. So you just check your number, 14. It is bigger than 10, so proportionally, this triangle, the solution did work out. Well, another example. I have an alpha up here. I'm going to make that alpha. It's a good choice. If I look across the triangle, the side that's not touching that, that's going to be what I put in for A. And if this angle is going to be beta, and I look across the triangle, find the side that's not touching it, that's going to go in for B. So I'm going to take these things, I'm going to set them up in the equation. Sine alpha, that's this angle, over 7, should be sine of beta, that's this angle, over 12. So I have a sine I can evaluate with my calculator. I'm going to do that. Sine 72 is 0.951. I can do this division, 0.951 divided by 12. I get 0.079. I need to get this 7 away from the sine before I can break it with arc sine, so I'm going to have to multiply both sides by 7. And 0.079 times 7 gives me 0.555 if I round. So I'm going to arc sine. And I end up with arc sine of my answer, 33.7 degrees. So in order for this to work out, I'd have to have a 33.7 degree angle across from a 7 in order for a 72 degree angle to make that side 12.